good morning and good afternoon to one and all. Welcome to the grand event of RedTeam Security Summit 2021. We would like to welcome and thank you all for being here with us today, as this is the second day of RedTeam Security Summit 2021. One another fabulous session. It's a great auspicious day for all Red Teamians. Once again, I officially welcome all the participants and the respected dignitaries to the Red Team Security Summit 2021. We are glad to announce another brilliant talk topic exploring and securing your Kubernetes cluster that will be hosted by Mr. Shikhar Joshi. It is indeed a special privilege and pleasure to welcome Mr. Shikhar Joshi sir to deliver this speech. Welcome, sir. Before that, I can give a short introduction of our honorable speaker, Mr. Shikhar Joshi. He is a security engineer by profession. He likes to explore the field of cloud application and product security. And he is a professional speaker on various security-related topics. He has achieved many certifications and licenses in his professional area. He has done projects on knowledge and information-based sharing portal and on automated SMS section for library. Definitely, his mentorship and wisdom will be a treat for all of us. So here we are overjoyed to invite Mr. Shikhar Joshi sir to our Red Team Security Summit 2021. I think everyone present here at this session was not only in awe of your knowledge, sir, but also greatly excited to see your presentation style. It will be a great pleasure to listen to your wise words and learn so much from it. Sir, now you can take the charge to deliver the talk, and the stage is all yours, sir. Thank you so much.
Thanks a lot,
You
Zazila,
can
for the
join now,
introduction.
sir.
So, hello,
Yes,
I'm
sir.
audible, right?
Yeah, it's
I'm
audible.
audible, right?
Yes,
Okay.
you are
So,
audible,
shall I
sir.
just continue and share the screen?
Yeah, sure.
Okay. 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 Good morning, everyone. So, okay, yeah, as introduced by Zazila, this section is all about, we're going to talk about certain things about securing and defending and knowing our Kubernetes clusters. So what I'm assuming is, like, if you have joined the session, you have basic knowledge about what exactly are containers and why exactly we need to use Kubernetes. Still, I'll just give a brief background. So in case if you want to come up from a monolithic approach and you want to go into a distributed system level, right? Then not necessarily, but the basic unit of implementation comes to the point of containers. Either it can be a Docker container, cryo container, containerd, and eventually you need some orchestrated platform in order to run them, or maybe you can say whatever what. Okay, either it can be Kubernetes, OC, or Docker Swarm, anything again, or maybe Cloud Foundry, whatever you want to use. But it depends upon what kind of implementation what you want to have. If you really want to talk about Kubernetes, the reason it has become really popular according to its, or when you try to compare it with other competitors, because the community is really strong, you have really good documentation, you don't need much resources in order to learn Kubernetes. You can just directly install it within your own operating system, or you can just buy uh, or purchase resources from AWS, or you can say DigitalOcean, whatever. Okay, so just a brief disclaimer before we even start the session. So as the name of the summit might say, RedTeam Summit, we are not going to follow the same approach for this session. I mean, I can just tell you, okay, so these are the attack vectors. You can just go ahead in Kubernetes cluster and you can just break it out. Okay. So we are not going to do that. What we are going to do is that we are going to explore the architecture of Kubernetes. Then we are going to look into what could be the design flaws, where exactly are the attack vectors where we can look into. Because once we know the architecture, no matter how Kubernetes has been created within our organization, or maybe you're a bug bounty hunter, whatever, you can just create a mind map according to you, right? Now, why exactly this is important? Because if you had heard about Kubernetes, or if you wanted to implement it, there are multiple ways in which you can create your own cluster, right? So for example, like AWS has given you your own service like EKS. So there you don't need to worry about majority of the Kubernetes components. It's just your customer data, your workload, that becomes a top priority. On the contrary, if you had a customized environment with you and you wanted to create in, you can create it on on-prem as well, or maybe you want to create a certain cloud technology and you're like, okay, I need to create a cluster from the scratch. In that case, not only you need to worry about the customer data, you need to worry about your infrastructure, your configurations, everything, right? So any point of time, if you want to go into the field of distributed systems, it's really good that if you understand Kubernetes, because even if you are not using Kubernetes, the other components of distributed networking, that starts making more sense automatically. Okay, so that was a brief introduction, like how we are going to go in the next 40 to 45 minutes. So I'll just go over the entire content. In case if anyone has any doubts, maybe the last 5 minutes we can discuss all the questions whatever we have. Okay, so yeah, let's get started. Okay, so okay, even before we start a brief intro, like I have been into Kubernetes and cloud technologies, their implementation for the last 3 to 4 years, I would say. So I have seen certain different ways in which Kubernetes has been installed. So I'll try to cover Kubernetes from an architect point of view. Okay. So what exactly is going to be the agenda? We are just going to look at the architecture first of all. Now there are multiple components which are being used and they club together in order to form a complete infra, right? Then once we have looked into that, we're just going to look into certain attack vectors which are always present in, I mean, not always, majority of the times which are going to be present in your cluster. And then while we are discussing about these attack vectors, we'll even try to see how can we prevent them. Okay, so this is the most basic architecture of a Kubernetes cluster. So now let's suppose we have any container technology with us. Let's go for Docker. Okay, so you have created certain Docker containers. So there was just one container. You just ran it up. Okay, it's running perfectly fine. But now let's imagine you have like 10,000 containers. You cannot do it on your own, right? So this is where you need certain orchestration tool where Kubernetes kicks in. So what you do is that you create your own 1,000 containers and you tell Kubernetes, dude, you just go and take care of it. I'm not going to do anything. So how does these components come together and do the job? So if you can see, there are com- two primary components. One is the control plane, one is the worker node. Okay, you can even say the worker plane as well. Now, this concept is gonna go same in almost all of the distributed system environments, right? If you want to create a Zookeeper cluster, Cassandra cluster, anything, right? So understanding Kubernetes not only helps you with Kubernetes, but with almost every aspect of distributed computing, right? So now let's try to talk about the master plane. Number one is the API server, right? So if you try to imagine what could be an API server, it's just an endpoint where you can send the request. So if you see, almost all of the arrows are pointing towards the API server. So what does this exactly mean? As a user, any system, as a service account, as a machine account, whatever it can be, it's going to talk to the API server first. Okay, whatever may be the communication, this is the entrance to the den, right? Now the next point we need to look into is one of the most important things, which is HCD. So you can consider this the database of the control plane. If you just get into HCD, your cluster is spawned. Okay, again, the only component which can talk to HCD is Kube API server. So this is how the communication could go. If you have exploited or explored the credentials to the API server, you have the complete access, right? Now the next term is the scheduler. Now let's suppose you wanted to create a cluster, and within your cluster you have created 1,000 nodes. What exactly do I mean by nodes? Let's imagine certain virtual machine. You are in AWS, you have spinned up like 100 EC2 instances. Now you don't know on which node you would want to create your container. Now let's suppose you wanted to create a container which needs fast processing, and you want it to be scheduled on an NVMe SSD. You don't want it to be scheduled on a HDD SATA hard disk. So you create certain restrictions and certain selectors, and depending upon that, scheduler schedules your pod onto those particular nodes. What does controller manager do? When we talk about certain other operations, we will look into where exactly control manager kicks in. Okay, now you might be thinking, okay, the API server is the most important part of this cluster, but in reality, API server does not do anything. Okay, what it does is, as soon as the request kicks in, it does some validation checks. Depending upon that, it sends the request to the new other components. Like for example, you have two different nodes. Let's say one is an NVMe SSD, the other one is a normal SATA hard disk, and you have decided, okay, I want to run my workloads on this NVMe hard disk, which is the SSD one. So you go there, and within that node, the API server, I mean, we don't go, the Cube API server goes definitely, and it starts talking to Kubelet, and it's like, okay, we have created a pod, we have scheduled it to on your node. Now it's your responsibility You'll take that container, spin it up, maintain its life cycle, everything. Okay, so kubelet is like a captain to that particular node, whereas API server is the captain of the captains. Okay, that is like a pyramid structure you could consider. Now what does kubeproxy does? Again, we're going to look into it. The next most important thing is container runtime, because if you want to spin up a container, you need to have a runtime, right? For example, what are these runtimes? So you would have heard about a high level runtime like Docker, Containerd, and Cryo. So these are the high level runtimes. What they do is that, let's suppose you do a Docker run Nginx. So it would just going to pull that particular image from the Docker hub or maybe any other repository. Then you have a low level runtime. When these cosmetic changes are done, so this low level runtime creates this image and spin up a container which is known as runc. So when you're talking about any container technologies, the drill down component which is responsible for managing your runtimes is a runc. Okay, so this is the overall architecture. We are going to repeat it once more. We have an API server. So this is the first point of contact, no matter you are a human, service account, machine account, or a component within the cluster. This is the point from which you are going to make any communications. HCD, your data store. Okay, anything what you are trying to, I mean, apart from the customer data, right? Any configuration information regarding your cluster is going to get stored in HCD. Scheduler is responsible for sending your workloads to where you want to have it running. Controller manager, we have not talked about it much. We're going to look into it in the next 5 to 10 minutes. Kubelet, kubeproxy, runtime. Okay, kubelet is the captain of that particular node. How the pod has to be scheduled, when it has to, I mean, when it has been divided by decided by API server, but you have to, entire life cycle of that container has to be maintained by kubelet. Okay, so we have looked into it. These are the master plane components and these are the worker node components. Just a myth, whenever we are trying to look into these components, kubelet generally is being only talked about the worker node component, right? But even in master node, there are multiple scenarios where you need to run certain containers, right? So in that case, kubelet is very, very important even on the master node front. Now, why I'm emphasizing on this? Because there are multiple attack vectors which happens on kubelet. And if our master node is exploited, again, our cluster is doomed. So moving ahead, if we try to look at from the call flow perspective, again, that would have been a bit confusing just looking at this particular diagram, like what exactly is happening and all. Okay, so let's suppose you are a user, you wanted to create a pod. Like if I go, I say kubectl. Again, we don't need to worry about the commands at this minute. Okay, so I run an Nginx pod and the image is Nginx. Now you might be, I think you might already know, but I'll just repeat it. What is the difference between a pod and a container? So if you're trying to run a Docker container, it's like, okay, Docker run Nginx and the Nginx container will get created. In case if it's a pod, it could have more than one containers. Does it mean that we are running two Nginx containers? No. The second one could be a helping container. Like for example, you run Nginx and with the second container, you can create certain logs. Okay. So this is a pod. A pod can have one or more containers. 90% of the times it would be just a single container. Okay. But those are the mutually exclusive containers. It could be a different one. If you are just creating same container, multiple same containers in a pod, you are not using it, right? Okay. So if you try to see, this pod is running now. Okay, so what exactly happened? We need to see what happened behind the hood. Because yeah, we all know we run the command and this is created, right? But we need to look at from the security point of view. We need to know where every endpoint is being called and what exactly is happening, right? So as soon as you type this command, kubectl create pod. So again, for Docker, you have something like Docker prefix, and here you use something like kube control, kubectl, whatever you like to call it. Okay. So first request goes to the API server that we have already looked into. Then you write it to HCD. This is what we have seen. Everything is being written to HCD. So you create a pod, you write it to HCD that, okay, I am going to create a pod. So at this situation, when you had written this command, your pod is already created. Okay. According to HCD, it's already created. You might not see it in a running state. So you get the response from HCD. Then you talk to the API server, talks to the scheduler. It's like, okay, boss, give me a node. These are my requirements. So scheduler try to look at all the nodes and he's like, okay, node 1 or maybe node 2, whatever the name of the node is, this meets our requirement. We can go and we can schedule our pod. Again, the pod is already scheduled. I mean, the pod is already created. Apologies. Okay. Then once the scheduler has done his job, API server talks to kubelet and kubelet is like, okay, I'll just create the pod there. and then the pod would be running, and whatever update is happening, everything is going to get written in etcd. Now the most important part is you can have any data stored within Kubernetes, right? HCD, again, it was the first thing which was introduced. It's like, you can say something like, I'm not comparing it to Redis, but something like Redis, which is like a key value store. You can even use Postgres, SQL, whatever you want to use where you feel comfortable, because there are different versions of Kubernetes which are coming in. It could be K3s, which is a lightweight version, k8s, if you feel like it is too heavy. So it depends upon you. You can just plug and play with the components and play it around. Okay, and you can even have a high scaling architecture as well, because the reason why you're using any distributed systems, whether it's Zookeeper, Consul, whatever, the main concern is availability. You don't want any downtime. Okay, so you could just create a load balancer in between, and you could have certain worker nodes. So if a master node goes down, you already have two master nodes. If a worker node go down, you can just push your pods from, or maybe you could say other terms like deployments or sets. Again, these deployments are on just the wrapper on top of pods. So this is the job of the controller manager, what we had looked earlier, right? Okay, in case if a node is not working, you can just push your workloads to the different nodes, right? So that nothing is lost. And the most important thing is HCD is like a secret to the den. You don't want it to get compromised. So even if your master node is compromised, you don't want HCD to be compromised. So you can just create a separate cluster or a separate node for HCD if you want to have it more highly available, more confidential cluster. This could be the way to go. Okay, now how exactly does this components communicate to each other, right? Because we have looked into it, right? If API server is communicating to HCD, now let's say they are just sending certain HTTP requests. So one HTTP request comes from API server to HCD, and you are like as an attacker doing certain man in the middle attacks, and you are like, wrong, right? So what should we do? Yeah, we should implement TLS. Now TLS is implemented, but let's suppose instead of API server, there is some other endpoint who is trying to talk to HCD. And HCD does not want it to happen. HCD only wants that API server should be communicating to HCD. So what we do? We implement a authentication mechanism which is known as a mutual TLS, right? Now, what exactly is, where was I? Okay, sorry. What exactly is the concept of mutual TLS? So let's suppose you try to access a website, let's say Google. When you try to put your FQDN entries like www.google.com, what happens is that your browser verifies Google certificate, and it's like, okay, this is the correct page. This is google.com. This is using a certificate of google.com. It has been signed by a certificate authority which I trust. So what I do is I just verify the server certificate. Now, what if Google is like only user one should be able to talk to me, not user two? Then Google has to verify its identity as well. So what we do is in Kubernetes, if API server wants to talk to HCD server, so what happens is API server validates HCD server certificate, and HCD validates API server client certificate, right? So this is how generally the components talk to each other. So if you know basic diagram, there's a mutual TLS. Mutual is talking to API server, against there's a mutual TLS in between. Similarly, for all the components, because you might say, okay, these are within the same servers only, or the entire control plane is within the same system. Do we even really need to do this all? Yes, you need to, because here we are not talking about the monolithic systems, we are talking about distributed systems. And how distributed system works, on a single machine, there could be like 70 to 80 different services. And if one of the services get compromised, your entire cluster would get compromised. So that's the reason we should consider all the services as like mutually exclusive. If they get compromised, they should not be able to take you down. That's the reason why mutual TLS becomes really important. Again, we can go deep into this certificate part. Again, I'm not going here, but you can look into like what could be the attack vectors. So what if you have implemented a certificate and the certificate was expiring 2 years afterwards, but some things happen, your private keys being exposed, they are being leaked. And if you have like revoke this certificate. Now, how can you make sure your cluster verifies that this certificate was already revoked? Maybe again, you can think about it, how exactly you can implement good PKI within your Kubernetes infrastructure, because I have seen in multiple locations, even if you have a good PKI infrastructure, and you're not revoking your certificates, or if you're revoking your certificates and if you're not able to identify whether this certificate was revoked or not, you're in problems. Okay, because how this authentication mechanisms like JWT and certificates, how they work, they have a specific time duration by when they are going to expire. So you would have seen, like in multiple web applications, you have a JWT token and the expiry is like 2 hours, 3 hours. Even in the case when the tokens are being exposed, or maybe user has logged out of the application, still you would see the JWT token would be working. So these are the points which we need to consider when we are implementing any authentication protocol. Okay, so again, that's too much on the major components. We don't have much time left, so I'll try to go to the other components as well, right? So we have looked into pods. So this is like a basic unit of Kubernetes. If containers were like electrons and neutrons, then pods are simply atoms, right? And when we are talking about Kubernetes, we are just going to deal with pods. We are not going to talk much about containers. Daemon sets are just a wrapper on top of pods. So let's suppose you as an attacker, you have already reached the internals of a cluster. You have the privileges to create some resources. So what you can do is that instead of creating a pod, you can create a daemon set. What daemon set will do is that, let's suppose within a cluster you have 10 different nodes. If you want to create a pod, the pod would create on one of the nodes. And if you want like certain scaling of the pod, then it can go on multiple. But when you're creating a daemon set, it gets installed on each and every node, right? So in that case, if it's a malicious pod, if you are able to scale up to an entire cluster, as an attacker, you should be looking at daemon sets. And within your cluster, if you see there are certain daemon sets running and you don't know what are these daemon sets and have you not created it, and it's something suspicious, then there's the first thing which you should look into it. Okay, now what exactly do I mean by volumes? So if you look at this particular diagram, because the container technology is ephemeral, right? You start a container, I mean, you can consider container pods as interchangeable. I'm just using the words, I mean, whatever gets in my mind. I'll try to use a correlated word like a pod here. So you create a pod, you delete a pod, the entire data is gone. So the entire data is gone. Now, what if there was some confidential data, you had created certain logs? How are you going to retain that data? So this is where your volume comes into the picture. Now, what you need to consider about volumes is that there are multiple kinds of volumes. You can use NFS, you can use iSCSI, you can use Amazon EBS, you can use host path. So now, what is a host path and why exactly I'm emphasizing on host path? So let's suppose you have a node running, and on top of that, you have created a pod. Within pod, you need certain data from the host. What really happens is that from the host, you have mounted certain directory to your containers. Now, just tell me one thing. We are trying to create a distributed architecture here, right? The nodes could come and go. We don't even know on which node our pod is going to get created. So why exactly do we need to use a host part data? All nodes could be different. We're not sure. So it's not a very good strategy for the customer data or for any data which is going to be stored in your pods. So anytime within your cluster you see a host path volume mount include, better be a bit worried, because apart from the management data, you don't need a host path, right? Like, let's try to see what could happen. So this is one of the YAML files what I have created. So this is the pod I'm trying to create. Again, don't worry about the commands. These are just easily available on the Kubernetes documentation. So what we do is that we create a volume mount. This volume mount is something like within the OPD directory of our pod, we are trying to have the etc directory from the host mounted. So let's try to see what are the contents of the etc directory. Okay. So this is the entire list of contents which is present in my node. Okay. Again, I have a one more node within the cluster. Both the machines are almost same. So we would have the similar kind of content there as well. So if I try to look into the nodes, this is actually a two node Kubernetes cluster, which is this master one and this is the worker one. So let's try to run this part. So you can just simply create a resource from the manifest file. Again, this is not much important. The commands and all are easily available. The more is about the concept and how exactly the architecture being created. So I'll do that. Let's see if the pod is running. Okay, the container is creating. Okay, one of one is ready and my container is running. So if you just try to do an exec, uh, okay, let me go to the opt directory. Okay, now the entire configuration within my worker node has been mounted here. Was there any limitation? No. You could do anything. You could even create this mount as read and write only. So there was this one particular scenario where we had to implement a host path volume. So there is a concept known in Kubernetes which is known as an admission controller. So even if you're authorized to perform certain actions, there are additional checks which as an administrator, I don't want any of my users to do. So what we did is that we had to implement an host path volume and we were like, okay, you can just access, let's say TMP directory, or let's say if you're solving a CTF like the flag directory. So what we did is that you can only mount that particular directory onto your cluster, and that too should only be in the read configuration. You cannot write anything to it. So this is how we prevented host path being exploited onto our machine. Make sure you use proper admission. I mean, admission controller is out of scope of this talk, so I'm not going to go much deeper into it. But you have to use it in case your cluster needs such kind of volume mounts, because volume mounts are really important. You cannot have the persistent data unless you don't have a volume mount. Okay, so this was all about the volume mounts. There's always a secret involved, right? So okay, before secrets, let's talk about namespaces. So you would have heard about namespaces in C++. Then you would have heard about concept like a Linux namespace. So now there's additional namespace in Kubernetes. Now what is the main notion behind using this term namespace? It's always about segregation. Again, it doesn't mean that it's going to be 100% secure, this segregation isolation, but whenever you want to segregate certain data, this is where namespace concept comes in. So in case of any distributed system, I guess more or less 8 out of 10 or 7 out of 10, you would hear this term namespace. Okay, similarly in Kubernetes, like for example, if we try to look into, let me get out of this container, kubectl get namespace. Okay, so there are like multiple namespaces running in my machine, and when I try to list kubectl get pods, so at this moment I am trying to access the default namespace. Okay, now if I try to go back to this particular container, right? So var run secrets. Again, so if you try to look into Kubernetes from the attacker's point of view, you would have heard about this directory, you would have read about this directory, but I'm going to tell you what exactly this is. Okay. So here you see there's something known as service account, and within there's something known as token. Okay. So what exactly is this token? Okay. Let's try to look into it. Okay, we have like 10 more minutes. Let me go here. Okay. So every namespace create a service account. That service account has some sort of token which is known as a secret. Now why this is important? Because even a service account might need to authenticate to perform certain actions. So this is where this comes in. You can even access kube api server from within your cluster. Okay, and that service account that time uses these secrets. So this is how you do a lateral movement within your cluster. So let's suppose there's an attacker who has already compromised one of your pods. Okay, so let's talk about this pod itself. So just before that, let me just run certain commands. Sorry. Okay, I run this command and then I go back. Okay, never do chmod 777. That's really bad, but it's okay now. Let's suppose your attacker has already compromised your pod and he is within your pod and he tries to look into like what he can do, what he cannot do. So he's like, kubectl, please answer me, can I create pods? So you need to identify what are your privileges. So at this moment, the token which I have mounted does not give me enough privileges to perform any other action. So it would be very difficult for the attacker to break out of the container and just try to move ahead to the API server and try to compromise etcd as well, right? So this is where we need to be very careful. Any service account which we're trying to mount, we need to verify the privileges that it contains, because what if your pod is just to run the Nginx server? You don't want to stored, right? There are ways in which you can uninform SL, so your service, your okay. So this was about the service account, and similar to that, we need to talk about RBAC as well. So RBAC was not included in the previous versions of Kubernetes, but now it is there, and it has become really important. When let's suppose again you had created a host path volume, you had implement proper admission controllers, but again you don't want every user to create a host path volume mount, right? So there you are like, okay, this is user one within namespace one, he can do it, but not user two within namespace two. This is where roles come into Kubernetes. Again, we don't need to worry about the commands and all. These are very easily available on kubernetes.io. Like for example, I'm not able to go to Chrome tab. If you go kubernetes.io and you are like, okay, I am just confused about any whatever, it could be pods or something else, you just go here, search about pods, and you will get the complete information. Okay, so this is the basic. If you want to see the detailing how exactly it might look like, you have created the same Nginx pod with the same name, namespace 1, namespace 2. You have a service account secret mounted to it. Although the names might seem similar, but these are isolated within different namespaces. Again, is namespaces secure? No. It just provides you certain segregation, and these could be broken easily. Kubernetes itself says is namespacing is not secure. Let's suppose you have pod 1 in namespace 1, pod 2 in namespace 2. Both the pods can talk to each other. There's no network isolation in between. For that, you would have to create using certain Kubernetes components. Okay. Volume, we have already talked about. Now, this is one of the important topics which I wanted to talk about. So, like, we have like 5 to 10 minutes left. Again, it's just a talk, so we won't be able to cover each and everything. But this is how your architecture generally gets created, right? What do I mean by that? Okay, so in Kubernetes we have a main system namespace. Okay, when oh sorry, not NDS, when we try to list the namespaces, you can see there's a system namespace. So this is where all the control plane components lie. Okay, let's try to list the pods within this particular namespace. Right, so if you see, there's an HCD pod running, there's a kube scheduler pod running, kube proxy, and whatever it might be. Okay, and I am not sure what happened to the Cube API server pod. Okay, I'm not sure. It generally should be running either maybe running a service or something else, right? So these are your control plane pods, right? How come they are already running their pods when your cluster is not even created? You can only create the pods when your cluster is created. So this is where the concept of static pods come in. Okay, so generally these could be in any location. Generally this is the place where the manifest files for the static pod lies. So if I go to this particular directory, so what really happens is you just need to put in your manifest files there, the kubelet is going to look into it, and your pod is going to get created. Even if you delete that pod, the pod is going to come up again. So you need to be very wary of who has a right access to your manifest directory within your cluster, because you might be wondering, okay, this is a virus or something. You delete it, again it's come back. So what it does is a short period, like 30 seconds, 40 seconds, the kubelet comes into this directory, look for the manifest file. Manifest files are right, syntactically, semantically, everything. They're just going to create a bot. Okay. So you have to be really wary about whoever tries to put in any content within these directories. That's very important. This is one of the topics which is not being discussed generally. But again, it holds a big security reputance. So where exactly things could go wrong? We have already looked into it. The tokens which are mounted into the pods, those need not to be really privileged. Uh, how the information is being stored in the volumes and all. Again, this list is not complete. Again, the 45 minutes was not what I would say like a huge time to discuss almost everything, but I just went ahead with a few of the concepts where we could look in, so that our we can secure our cluster from getting compromised. So these are the few of them. Again, yeah, I think even out of these we were not able to cover many, but again, if we're trying to just go into each one of them, we are not even going to consider even one or two. Okay, so any questions regarding the topics what we have discussed till now? Or if we'll have like there are no questions, then we can cover these topics as well. I'll just take hardly 5 to 7 minutes. I've intentionally not gone over. Okay, if there are no questions, then just look at these points once. uh, So what exactly do I mean by authenticated services? Like for example, if you want to talk to kubelet, generally what is happening is people tend to leave the kubelet port open. This used to happen in like 2017, 2018. But now by default, if you're trying to create your cluster using good ways, you would have your kubelet port authenticated. But is that enough? No. So kubelet also has some authorization problems, because I remember when I was doing a security assessment for one of the Kubernetes clusters, they were like, okay, I am checking you for authentication, but I don't care about authorization. If you're authenticated, I'm good to go. So the pod which I had running was, it was like the service account had no privileges, right? But then I could just talk to the kubelet endpoint and boom, the whole cluster was compromised. That again went as a huge security risk. Static pods, we have already looked into it. There's something known as admission controllers and authorization. So just imagine you want to run a pod and you always want your images to be pulled from a registry, not from a local system. Now where it can go wrong? So you are like, okay, the image is already present in my local system, why do I need to go to the repository? Let's take an example. Within the registry, you had like a super secret image. User one had the access to the repository, so he can pull that particular image. What if there's a user two who does not have the access, right? And the image is already lying within our local machine. So you don't want that to happen. Any pod you want to start, it's like you pull the image, then only you are going to start the pod. Okay. We have looked into the scenario. We authenticate the pod, or let's say the service account and user who's trying to create the pod. We have authenticated, then we are like, we have authorized, okay, you have the right to create the pods, that's it. This is authorization, right? Generally when we're talking about the security concept, it's like, okay, user is authenticated, user is authorized, we are good to go. But that's not all. We have already discussed that we want the images to be pulled from the repository. That does not deal with authentication and authorization. That checks are already passed. So this is where the concept of admission controllers come in. They're already predefined admission controllers which are present, but you can create your own admission controllers as well. So this is a one which is already given by Kubernetes. You implement it, no matter with how many versions the image is present in your machine, cluster won't allow the pod to get started with that image. It has to be pulled. Okay. This is a very, the next one is not paying attention to labels and selectors. So I think this is pretty funny one, because let's suppose you wanted to create something like a it's going to take 5 more minutes on it. So what exactly do I mean by replication set? So let's suppose you created a pod of an Nginx container and you are like, I want to have the 5 replicas of it. So you just put a wrapper on top of that pod, which is like a replica set, and now you have 5 Nginx running. So how the replica set is going to realize that these pods are under that replica set? Because of the labels which you put on top of that. Now, what I did once with one of the clusters is I created a different replica set with the same selectors, and 2 replicas were running. And now the legitimate replica set, when it came with the 5 scaling factor, it was only able to spin up 3 pods. Now the administrators were like, what is happening? The replica count should be 5. The only problem happened because there was no authorization point on who can use what type of selector. When I created my replica set, I had already used that selectors. So now the matching is 5, which are already there, but the legitimate number of instances were only 3. So again, this is again a problem which is hardly looked into, but again, this is a big security risk. We need to be very wary of who can implement what kind of labels, who can remove what kind of labels, and who can put what kind of selectors. Okay. So yeah, that was the entire deck which I wanted to cover. And in case you want to reach out to me, again, we will share this PPT. So you can just contact me on my mail ID. You can just contact me on Twitter, or you can just reach out to me on LinkedIn. I'm always open for discussions. So yeah, that's it from my side. Do let me know if you have any additional questions regarding the talk. Hello. Hey, hi Jazila.
Hi, sir. Sir, it was a nice presentation done by you. Can you hear me, sir?
Yeah, yeah, I can. It's
Yeah.
audible.
Thank you, sir. It was a fabulous topic. I would like to take this opportunity to thank you for giving upon your valuable time and to talk at our program today about Kubernetes cluster. And it was awesome. We were really thankful to you for your sincere and patience with us, sir. First of all, congratulating you for this rare quality of your presentation. Thank you, Shikhar Joshi, sir. And we appreciate having this mysterious area clarified by you, bringing your expertise and experience around the session and engaging in such a fruitful and constructive and open exchanges of your researchers throughout the time. Today, you discussed in particular examples around the topics architectures of k8s cluster, Kubernetes cluster, components of Kubernetes, how can we prevent the attacks of Kubernetes, master plane components, and kubelets, etc. All type of topics you have covered in this session. I think it was so informative for the students and participants of this session. So we can ask the audience if they have any questions to ask you. I think you already asked the audience, right, sir?
Yeah, so I think I have this one question from Vivek. Like, what are the different ways of using Nginx server for load balancing? I mean, I
Yeah.
did not completely get the question on what context this was about.
Okay. So Vivek, can you ask clearly the question if you want to ask?
Hello.
Hello. I don't know, please.
And okay, by the time Vivek is coming in, so I have one more question. Can you suggest more practicing side on it? So I'll suggest there's a website known as Katacoda where you can start with it, but I'll highly suggest that you create a one node Kubernetes cluster directly onto your machine. If you have like an 8 GB RAM, you can create a single node cluster as well. But I'll prefer create a two node, one for master and second for worker node. You will have the direct steps within certain repositories like created by Mumshad, or you even have what I have used for this session was Vagrant, right? So I created my cluster using Vagrant, so it was really easy for me to set it up. And then you can just go ahead and you have the complete list of commands on kubernetes.io, like how exactly can you install it via kubeadm. There are other ways as well, but I'll suggest you go with that.
Okay.
Okay.
Okay, that question may be cleared. Okay, sir. Thank you, sir. So, next question we have: can you suggest any practicing site for developers or?
Yes, yes.
Uh,
Yeah, this is what I answered just now. Okay, practice site for DevOps or DevSecOps, please. That will involve Kubernetes and other things. Uh, Practice sites. So actually, what I would do is because again, I am not from DevSecOps, so basically I started my career from offensive side. So whenever I wanted to learn something from the DevSecOps part, I try to create it on my own machine. Whenever I don't have it my machine, I'll use something like DigitalOcean. I'm not promoting anything, but that's much cheaper as compared to AWS. So if we talk about free sites, mm, or anything like
free
that.
sites.
Okay. Uh, I'll always refer Katakoda. So this is where I started with it and I love this site. So what exactly would happen is if you go to this particular site and you create a scenario like, okay, I want to learn Docker. So it's going to give you a web shell kind of a terminal, and there you can just do your work. I mean, it's not going to store the state only for an hour, but that would be enough. Let's suppose you wanted to create a particular scenario. You're like, I want to go deeper and want to create a network namespace scenario in Kubernetes. I think someone would have created the scenario in Katagoda. So I'll highly recommend that particular website.
Okay, sir. So, audience, can you give any more questions if you want to ask Joshi, sir? I think no questions more, sir. Thank you,
Okay.
sir, and thank you for participants for the great cooperation. I hope you all have taken the benefit from the great topics happened throughout the days. You are the pioneers of our events, students. We wish you all good, sir. We wish you good health and success in your future endeavors. Thank you, Joshi, sir. Once again, there is so much more to learn from your knowledge and experiences. I hope we can meet soon in another session. So, guys,
Sure.
yes, sir. Thank you so much. Okay, sir. So, guys, now we have an upcoming session by Mr. Kumar Ashwin on the topic: Are your containers really secure? So, the session will start at 1 p.m. after a short 15 minutes of break. It's okay. So, please stay tuned and switch over to the next session. Thank you all. And now a massive thank you to all our event partners, supporting partners, community partners, media partners, and tech partners for this year's RedTeam Security Summit. Okay. We are grateful for your continued support of this essential event, which continually challenges young security professionals across the globe to develop their skills and gain the practical experiences needed in this industry. So thank you all. Guys, you can go and check out the booths in the left-hand side of your screen on which you can discuss with the stalls of Red Team Hacker Academy and Hack the Box about more details. Thank you for all your great cooperation once again. Here we are winding up this session and have a good day to all. Thank you.